Hello, this is Muhammad Usman, and today we are going to discuss some of the measures of variation. So, let's just start it now. Variation. Well, measures of variation they are also known as measures of dispersion. And what does dispersion mean? It is known as variability, scatterness, or spread. Well, basically, the measures of variation they are to measure the variation in the data, and the following measures they have been used for this purpose. Variance and standard deviation, the most widely used measure. Range, interquartile range, semi-interquartile range or quartile deviation, and the last one is mean deviation. So, the first one, variance. Variance is a measure of the spread between observations in the data set and how the values they have been dispersed from their mean. Well, again, keep in mind the concept of population and sample in your mind. Well, now you can see the formulas for population variance and sample variance on your screen. Just moving forward, now we will discuss standard deviation. It is the positive square root of the variance. So, in case of population and in case of sample, you just have to take the square root of the variance. That will give you the standard deviation. And this is the example in which you will calculate the variance and the standard deviation. Consider the data of yield of wheat in kilograms from 8 experimental plots as under. So your task is to calculate the variance and the standard deviation. So first of all, remember that for the calculation of variance, you need to calculate the thematic mean. This is your data, and the mean simply can be calculated by dividing the sum of all observations with the number of observations. And in second column, you calculate the deviations of observations from their mean, that is always 0. And by squaring those deviations, you will get the variance, which is simply to divide the sum of squared observations, sum of squared deviations to n minus 1, and then simply take the square root of the variance in order to get the standard deviation. It's simple calculations. And from here on, just keep in mind that there are two types of measures used to measure the variation: absolute and relative. Absolute measures they have the unit, whereas the relative measures they don't have any unit. They are unitless quantities. Relative measures are being used for comparison of different data sets. So now we will discuss the range. Range is simply the subtraction of the minimum value from the maximum value of the data. It has the unit and it is the absolute measure. And the corresponding relative measure for range is coefficient of range. It has no unit. A simple example in which you can see that the range is 16 and the coefficient of range which have no unit is 0.2. Semi-interquartile range or quartile deviation. Well, for calculation of semi-interquartile range, you need to calculate the interquartile range first. It is the subtraction of the first quartile from the third quartile. And when you divide this number by 2, you will get the quartile deviation. The corresponding relative measure for the quartile deviation is coefficient of quartile deviation. You may use the coefficient of quartile deviation for comparison. And the last measure is the mean deviation or average deviation. Well, we can calculate the mean deviation from mean or from median or from mode. The formula is on your screens. And the corresponding relative measure for mean deviation is the coefficient of mean deviation, where you divide mean deviation with mean or median. The corresponding relative measure for standard deviation or variance. The formula is the standard deviation divided by the mean multiplied by the 100. Here is a simple example in which I will try to elaborate the concept of coefficient of variation. These are two different kinds of data. On the left side of your screen you have a data which represents the prices of certain commodity in rupees. On the right side of your screen you have a data which represents the life of car battery in hours. You calculate the mean and variance of both the data sets, and the question is in which data set there is more variation. But you cannot compare standard deviations here, because standard deviation is an absolute measure. It has a unit. So you cannot compare rupees with hours. So for that purpose you need to calculate the coefficient of variation. Coefficient of variation may be calculated by just dividing the standard deviation by arithmetic mean and multiplying the resulting fraction with 100. And now you can compare the CVs of both data sets in order to assess that in which data set there is more variation. Well, another very important topic is the type of distribution. Well, if the values they are equidistant from the central maximum, it is the symmetric distribution. And if they are not equidistant, then it is not symmetric, and if it is not symmetric, then it is skewed. And skewness may be right skewness or left skewness. Right skewness is also known as the positive skewness, and left skewness is also known as the negative skewness. And here is the measure of skewness, that is known as coefficient of skewness. There are two formulas from which you can calculate the coefficient of skewness. You can use any one of them. And if the skewness coefficient is 0, that means the distribution is symmetrical, that is, there is no skewness. And if that coefficient is greater than 0, that means the distribution is positively skewed. The greater the number, the shows the strength of the skewness. And if the coefficient is less than 0, the distribution is negatively skewed. Another very important aspect of the type of distribution is kurtosis. Well, it describes the extent of peakness or flatness of the distribution. You are watching three types of distributions on your screen, one with a blue line, the other one with a red line, and the third one is for green line. All those distributions they seem symmetric, but they are different in terms of their height. So this height is measured by the coefficient of kurtosis, and the formula is as under. And if this coefficient is 0, the distribution is mesokurtic, and if this coefficient is greater than 0, the distribution is leptokurtic, and if this coefficient is less than 0, the distribution is platykurtic. Here is a short example through which you can calculate the coefficient of skewness and coefficient of kurtosis for your practice. These are the answers for you. Just try it out and just find the measure of skewness, measure of kurtosis, and interpret your result. One very important topic is the box and whisker plot, which we are going to discuss shortly, but before that we will see what is the 5-number summary. If you can calculate the first quartile, the median, the third quartile, in summary you can construct the box and whisker plot, which is quite informative. Well, you have to locate these 5 numbers on a scale, and the first quartile, median, and the third quartile, they will made up a box, and from the outer side of the box, the upper and the lower limit of the data, they will form whiskers. So this is jointly known as box and whisker plot. The green line shows the first quartile, whereas the red line in your screen shows the median, and the third line, the pink one, shows the upper quartile, that is the third quartile. A line within the box indicates the average size of data. Length of the graph indicates the variation, whereas the center line, that is the red one, the median line, it indicates the type of distribution. If that red line is right in the center of the box, it will indicate the data is symmetrical. And if that line is above the center, like in the picture above, your data will be negatively skewed. And similarly, if that line is below the center, the data would have been positively skewed. And here is a simple example of 20 students, the marks of 20 students, from which you can calculate the 5 number summary, and you can draw a box and whisker plot for your practice. Here is another example of 20 test pieces of certain alloy, and your task is to complete the average and the standard deviation, and one additional thing, that is, you need to calculate the interval mean plus minus 1 times standard deviation, then the mean plus minus 2 times standard deviation, and at the last mean plus minus 3 times standard deviation, and assess how many values they're falling in those intervals. So, one very important aspect here, the distribution of the data, the curve, that will be a normal curve if about 68% of the observations fall between plus and minus 1 standard deviation from the mean, and if 95% falls within 2 standard deviation of mean, and 99% fall within 3 standard deviation of mean. Well, thank you very much.